Hey everyone, the nerds are back this time to see what a sequence of numbers sound like. In our last project we showed you a geometric way to find the chords in any mode. Today we will show you how we created a piece of music using the sequence of prime numbers. Our first step was to give ourselves a mathematical basis for the notes in a scale. Here we have listed all the tones in one octave and have associated a number with each of them. For future reference, we will call these the chromatic values of the notes. This will give us a mathematical basis to relate the notes to our numbers and to each other. Next, we need to remember how we defined harmonic intervals in our previous project. Looking at the chromatic scale, or the chromatic values, we define a semitone to be the difference of 1 mathematically, or musically we know this as a half step. In Western music, our chords have typically been built on intervals of 3, 4, 5, 7, 8, or 9 semitones, also known as thirds, fourths, fifths, and sixths. These will be the intervals we use to build the harmony part of our music. Using these two concepts, we are ready to compose our prime number duet. We have used Excel to do these necessary calculations. This also allows us to change the mode quickly to see how the prime numbers sound in a variety of settings. This spreadsheet shows the calculations for the key of A major. In column A, we posted a list of the first 500 prime numbers. Column B uses what is known as modular arithmetic. In this case, we simply divide the prime number by 8, and the remainder of that division is listed in column B. We chose 8 in our case so that the remainder would be between 1 and 7. The A major key has 7 distinct tones. We have associated each of these notes with a value from 1 to 7. The note that is associated with the number in column B is listed in column C. We have generated a melodic line for our piece. Remembering the harmonic intervals, we recall that there are 6 of them. 3, 4, 5, 7, 8, and 9 semitones. So our next step is to do modular arithmetic. This time, dividing by 7 to get a value from 1 to 6. This value is listed in column D under mod 7. The harmonic interval associated with this value is listed in column F under harmonic interval. The chromatic value of the melodic note is listed in column E. Our next step is to subtract the harmonic interval from the chromatic value of our melodic line. This gives us a new chromatic value listed in column G under harmony note chromatic value. The chromatic note associated with that value is listed in column H. And finally, if that note is in our selected key, it is listed in column I. And if it is not, we have simply written a 1. Which we interpret as a rest. This process works for any key or any mode. We simply change the modular arithmetic and redefine which notes our numbers are associated with. We have several examples of what came of this process using different keys and modes. Our first example is in A major. The melody is a bit jumpy, but this is a simple proof that our crazy idea just might work after all. The Hungarian Gypsy mode is an 8-tone mode that you might not be familiar with. Here you might notice some notes that are a bit unexpected. Here we've done the same thing in a jazz mode known as the blues mode. The six-tone blues produced my favorite melody, so I wanted to work with it a little more. Unfortunately, the harmony line that we got gave us only a single note, A. However, as it is a jazz mode, we decided to include 6 in our list of harmonic intervals. This allows us to have diminished and seventh chords, and added quite a bit of variety. Lastly, we used the method before described to generate our notes, to assign different rhythms to those notes. We also added a third line of music up higher as sort of a counter melody. This required minor interpretation on our part to add phrases and make things sound a bit more complete. But this is my favorite, the Prime Blues. Different sequences and different modes will, of course, generate different melodies. The possibilities are endless, so have fun.